So let's pick up this video with the question we looked at the very end of the last video, which looked like a question that might involve the product rule, maybe the quotient rule, but the exponents are a bit different because they're not integers. So let's first try to apply what we know involving the product rule or the quotient rule or the power rule to look at this problem. So when I first look at the numerator, I have a factor, a base of a, and a base of b. These are not like bases, so I can't really do anything at this point with my numerator. I'm just going to rewrite it. But I can do a little bit with my denominator. I have the power rule being applied in the denominator. Both a and b are being raised to the first in the parenthesis, and then there's a power of 1/3 outside of the parentheses. So I'm going to raise both a and b to the 1/3 power. So there we looked at the power rule. Now I have like factors of a and like factors of b being divided. So now I'm going to refer to my quotient rule. And again, the quotient rule says that you can take like bases that are being divided and subtract their exponents. So a to the 4/3 over a to the 1/3 would be a to the 4/3 minus 1/3, which would actually be 3/3. 4 minus 1 is 3, and then we have a common denominator of 3. B to the 2/3 minus 1/3, because I'm dividing b to the 2/3 by b to the 1/3. 2/3 minus 1/3 would be 1/3. Again, use your calculator if you're not as comfortable, adding and subtracting these fractions. I should end up with an a to the first and a b to the 1/3. But when I look at my choices, I do have a couple choices where a is being raised to the first, but if you look, all of these choices also have a cube root in them. So maybe I can get rid of choice 1 and 4 here and leave myself with the ones that have a to the first. But at this point, we're not ready to figure out what b to the 1/3 is equivalent to in terms of a radical because we haven't learned this rule yet. So we're going to come back and finish this question after we discover and talk about the fractional exponent rule. So fractional, sometimes referred to as rational exponents, it's just another way to write an equivalent radical expression. So anytime you have an exponent that is not an integer, that's a fraction, it's just another way of writing a radical expression. And the relationship is between this numerator and denominator of your fractional exponent in relation to the index, which is also known as the root number of a radical, to the power of the thing underneath the radical, which we sometimes refer to as our radicand. So I'm just going to highlight a couple of things here that are related, and then let's talk about this rule. So when we have x raised to a fractional exponent, we talk about x being raised to a power over root, or sometimes we'll say power over index, but I'm just going to rewrite power, which we already had here in red, and then I'm going to call n the root, which is also called the index. We'll refer to that in a moment. So if you had something, I'm just going to write under here, something like x to the 2/3 power. What you're going to do to rewrite this in an equivalent alternate way is to write it as a radical expression. Now, the power, the 2, is actually going to stay the power of x, so that's going to still be x squared. But the denominator, the 3, is now going to become the index or the root of my radical. So where we put the index number or the root is in the hook of the radical. So that's where this 3 would go. So here's my 3. Here's my 2. So the cubed root of x squared is an equivalent way to write x to the 2/3. Another way you also could write this, sometimes the power doesn't have to be under the radical. It could actually be outside. So this is just another equivalent way of writing the power. It's still the power, but it can be written either inside the radical or outside. But the denominator is always going to translate into that index or root value of your radical expression. So let's go back to that question. We knew we had a raised to the first, and we also have b being raised to the 1/3. So now let's just translate what we just learned. That's going to be my power. This is going to be my root or index number. So here's my power, here's my root. So if I go to write this as an equivalent radical expression, the b should be under a cubed root and being raised to the first. Now, because we don't always write powers of 1, even with the a, we don't typically keep writing that. It could be written without that power of 1 and just be simplified as a times the cubed root of b, which now we can see is a choice here, this second choice. So now let's try to apply this rule a few times. So if you were given a question like this, write this expression in exponential form. Exponential form is where we have x raised to the power over root. Radical form would be the opposite, when the root is in the radical as the index number, and then the power is either under or outside of the radical. So those are two versions of radical form. So right now we're in radical form and we want to go to exponential form. This should be equivalent now to x to the 2 over 5 power. Power over root. Let's try one more like this. So we're going to write this expression now in exponential form. So take that power of 4, make that your numerator, take that take that root of 3 and make that your denominator. So the cubed root of x to the 4th is equivalent to x to the 4/3 power. Let's try one more. I know I said one more before, but let's do one more, because anytime you see a radical and the number or variable underneath it doesn't have an indicated power, you just have to remember that there's a 1 there. So this is equivalent to x to the 1/4. And while we're talking about things that you don't always see written, let me just go through the alternate way you could be missing a value if you had something like this. So not only am I missing the power of 1 here, I'm also missing the index number, because we don't always write the index if it's a 2. It's the only time we just assume we have a square root when we don't see the index number written. So I would need to know that if I just saw the square root of x, that's equivalent to x to the 1/2, because again, there's an exponent of 1 that we don't write, and there's an index of 2 that we don't write. Okay, so now we're going to go the other way. Now we're in exponential form, and we want to go to radical form, which again would be the root and then x to that power. And you always have the option too of putting the power outside of the radical. So we have x to the 2/5. So that's my power. That's going to stay my numerator. And this denominator of 5 will be my root. So this is going to become the 5th root of x squared. You also could write the 5th root of x squared. Either form is fine. You do not need to write both. Just one of them would be equivalent. X to the 3/4 would be the 4th root of x to the 3rd. Power over root. Why don't you try this one? Pause the video for a second, give it a try. And for this one, you should have ended up with a power of 1 and a root of 5. So the 5th root of x to the 1st, again, you don't need to write that 1. You could just have it as the 5th root of x. Now, let's just take this rule and see if we can apply it to a couple questions that maybe have more than just x being raised to a power. So in this question, we have 25x in the parenthesis being raised to the 1/2. So if we think first about the power rule says both of these things are going to be raised to the 1/2. So I have to take my original power of 1 for 25 and multiply it by 1/2. My original power of x, which is 1, and also multiply it by 1/2. So this power rule reminds me that both of these factors are being raised to the 1/2. So if you want, now we can go to thinking about, well, what does that mean? So the 1 is the power, the 2 is the root. So I'm really putting, if I want to go back to before I expanded this, I'm putting this whole expression 25x under a square root because, hold on, forgetting my x here. I have, oh, now I'm forgetting my 5, Mrs. Carnes. Sorry, guys. 25x, that whole thing is still being raised to the first, and it's underneath a square root. So now we have to think about, well, what is the square root of 25x? Can I simplify any part of that? Well, I can because 25 is a perfect square. So that can come out of my radical as a 5, and the x would still be under the radical because that is not a perfect square. So now let's look at some of these choices. Which one is equivalent to? So we know that the square root of 25x is. We also know that 5 times the square root of x is. Again, this isn't something we're actually clicking on, but so far I have 2 answers in a multiple choice. That's not typical. So they do give me a choice that says all choices. So that means that this last choice, 5 times x to the 1/2, must also be equivalent. So let's just look back at our final answer. If I wanted to write this in an equivalent way, I could bring the square root of x back to fractional exponent form, which would be a power of 1 over a root of 2. So this is also equivalent. Again, the 5 only has a power of 1 because we square rooted 25, which means we raised 25 to the 1/2 power, and we ended up with 5. But the x still has that power of 1/2. So that would be all choices. Okay, I hope this video was helpful to introduce the equivalency between a base raised to a fractional exponent and its radical form. In the next video, we're going to talk about negative exponents, and we're also going to review fractional exponents in that lesson as well.